the objects. So these are the contents that I will cover today. So coming to the class diagrams, the UML diagrams are divided into the two parts: structural UML diagrams and behavioral UML diagrams. Class diagrams and object diagrams are the structural UML diagrams. Class diagrams are the main building blocks of every object-oriented methods. The class diagram can be used to show the classes, relationship, interface, association, and collaboration. Whenever we use class diagrams in any project, the main aim behind using it is to show how different classes interface with each other. What are the relationship between the different classes? What are the association and collaboration? To explain this, we use class diagram. Each class is represented by a rectangle having a subdivision of three components: name, attributes, and operations. Class representation is rectangular, in which three components are there: name, attributes, functions, or methods. So name, this is the minimum requirement in class diagram. It represents a name or for class or concept. A class encapsulates state, attributes, and behavior, that is operations. So name is the minimum and compulsory requirement for any class representation. What does this mean? This means that if we define any class, if we represent any class without any attributes or behavior or operations, then it is okay, but the name should be present there. The name is the minimum and compulsory requirement for class representation. Class encapsulates state, attributes, and behavior operations. Every attribute has their different data types. Their data types are defined within a class, like integer, string, date, etc. Similarly, every operation has a signature. What is a signature? Signature specifies the parameters of a methods, their data types. Parameters are what? The parameters are the attributes that operation or method takes as an input and process on them. So their data types is also mentioned in the signature, and the return type of that method is also uh, the return value, and the data type of return value is also there in a signature of method or operations. Then access modifier. There are the three access modifiers available in C++. These are the public, private, and protected. If you do not specify any access modifiers for the member inside the class, then by default the access modifier for the member will be private. Public access modifier. All the class members declared under the public specifier will be available to everyone. Everyone means any class which is present in a program. The data members and the member functions declared as public can be accessed by other classes and functions too. The public members of a class can be accessed from anywhere in a program using the direct member access operator. So the member access operator is dot symbol. So this dot symbol is a member access operator. Using this access operator, we can use public members like attributes, public attributes, or public methods anywhere in a program in which that particular class is used with the objects of that class. We can't use directly class. We have to define objects. We will see it later. Then private. The class members declared as private can be accessed only by the member functions inside the class. They are not allowed to be accessed directly by any objects or functions outside the class. Only the member functions or the friend functions are allowed to access the private data members of a class. That is, what are the friend functions? The friend functions and the functions within which that private attributes or private method is defined. Only they are allowed to access the private attributes or the private methods. Then coming to the protected access modifier. Protected access modifier is similar to private access modifier in the sense that it can't be accessed outside of its class unless with the help of friends class. The difference is that class members declared as protected can be accessed by a subclass, that is derived class of that class as well. So let's consider there is one class called as an animal, and within that within the animal there are the different class uh, uh, which are the, animals like humans, dogs. Suppose there are the different classes, then all the properties, all the attributes, and all the functions which are defined for class animal will also be inherited by the classes as human, dog, or xyz. So these class like human, dogs, and suppose these are child or subclass of these class animal, then all the attributes and operations are inherited automatically by the property of inheritance. Then these protected operations or protected attributes which are defined in the class animal can also be directly accessed with the from the classes like human and dogs, because they are the child, they are the subclasses of the class of superclass. Okay, this access through inheritance can alter the access modifier of the elements of base class in derived class depending on the modes of inheritance. Okay, example, a class rectangle. So consider this example of class rectangle. So in this class there are the three compartments and which has name, attributes, and these are the operations. So the name of this class is rectangle, attributes are width and length, and the operations are set width, set length, get length, and get area. So in this class, what you can observe, this class has the two attributes with a data type. So we define the data type as we discussed earlier. This data type is double, and the access modifier is private. So these attributes are only accessed by the objects of the same class. Then operations. These operations have the parameters, their data types. So here double is a data type of the parameter which is accepted by a set width operation, and the return value and the data type of return value as well. So you can you can uh, you can understand from these how why the signature is important in any class um, model. Then attributes. Attributes have values. It represents properties of a class. So for example, consider a class rectangle. So length and width are the properties of a class. These are represented by attributes within class. Every attribute have data type defined in a class. So here the attributes length and width have data types which are defined in a class. A set of attributes with their values represent a state of an object. So let's consider there is an object rectangle R1. So R1 has width equals to 5 centimeter and length equals to 10 centimeter. So this the set of attributes length and width with their values 5 centimeter and 10 centimeter represent a state, represents one state of object. So and after by performing operations on the object, we can change the state of an object. So if we change the length to 15 centimeter and width to 10 centimeter, then the set of values will be width equals to 10 centimeter and length equals to 15 centimeter. This will be another state, state 2, second state you can say. So the in short, state is the set of attributes with their values. Okay, again a set of attributes with their values represents a state of an object. Attributes appears in the second compartment just below the name compartment. So this is a name compartment. Just below the name compartment, attributes are there. Attributes in a class, in the previous class, width and length are the attributes. Attributes have their data type. For both of them it's a double. So in this both of the attributes, that is width and length, their data types is double. Again, also access specifier is private for both attributes, means these attributes can only be accessed and modified by the methods of same class like set width and get width. So the access modifier is private. So these attributes, if we want to change this attribute, then we have to use the functions or the methods which are defined within the same class, like set width, get width, set length. By using these methods, you can access these private attributes. Attributes can be derived as well. Example, age of a person can be derived with the help of date of birth and the present date. These derived attributes are represented by a backward slash symbol before the attribute name. Then coming to the methods, method is a collection of statements that perform some specific task and return the result to the caller. The method can perform some specific task without returning anything also. Then the return type is by default void. Methods allow us to reuse the code without retyping the code. So when we use the methods, when the same type of operations has to be performed again and again within a program, then at the time we define different methods. So what is the function of a method? There are different statements, the sequence of statements in a method, and the method executes operations, executes that method or that sequence of statements, and the operations return some values, specific values, and operations also needs some parameters, like we have discussed in this class. So suppose a set width will take one parameter having data type double and will return a value with a data type boolean. So it needs input as well for the output. So after then attributes in a class, then methods. So we can reuse the code without retyping the code. So this is a main what we can say, this is the main advantage of using methods. So method declarations. So there are different methods like modifiers, then defines class type of the method, that is from where it can be accessed in your application. In Java, 4 types of access specifiers are there: public, protected, private, and default. So we have just discussed this, all these access specifiers. Then public is accessible in all class in your application. Protected means accessible within the class in which it is defined and in its subclass. Subclass means their child classes. And private, accessible only within the class in which it is defined. And by default, if we don't define the access modifier of any method, then there are it is declared or defined without using any modifier, then accessible within the same class and a package within which it is its class is defined. It is you can say it is a private. So let's take the example of this class. In this class, this is a class name. So sorry, let's take the example of method. So this is a method. There is a return, this is a modifier. Public is a modifier. Then return type is given, integer is return type, and the method name. Max is a method name. Then parameter list is also given. X and Y are the parameters. Their data type is also mentioned. Then there is a statement body of the method. There are the set of statements which are executed, and a particular value is returned. So X or Y will be returned. So there is a return value is also mentioned in a method. Then coming to the object-oriented methodology. An object is an identifiable entity with some characteristics and behavior. An object is an instance of a class. When class is defined, no memory is allocated, but when it is instantiated, that is an object is created, memory is allocated. So class is an instance of object is an instance of class. So when a class is defined, so class is the information, or you can say class is a structural body of any object. But when the class is defined, memory is not allocated. When the object is created, at that time only the memory is allocated. Okay, so let's take the example of this class person. This class has a name, a character string called as a name, then integer id, which and then public get get details, public operation. Okay, so when this class is defined, no memory is allocated. But when you will run this line, that is person p1, so person is a class and p1 is an object, At that time only the memory will get allocated. Then objects has a set of values, value for each of its attribute called as a state. Then set of actions that it can perform, that is behavior. Okay, and an identity, uniqueness in a domain or class. Every object has its own memory to hold its state. State is a set of attributes with their values. When we perform operations on an object, its state changes. Object take up space in memory and have an associated address. So whenever any object is defined, at that time the memory is allocated in a memory system and the address is also assigned to that object. So let's take example of this object. So student is a class having attributes name and roll number. So this is an object one called and the name of object is Adam, and object two the name is Kesha. So when this class is defined, no memory is allocated, but when these objects are created, then memory will be allocated, because we have to save these values, that is the name of this person, okay, and their roll number. We have to save this information. For that reason the memory is allocated. Okay, then coming to the next part, each object will have its own inherent unique identity. In other words, two objects are distinct even if all their attributes, values such as name and size are identical. So let's take an example of, suppose there are the two objects, object P1 and object P2, and suppose these objects have the same set of attributes, and their data types are also same, the attributes name is also same and their values is also same, but there are some properties which are inherited by an object from its class. So let's say these two objects are from different classes, class 1 and class 2. Okay, so class 1 has some different properties and class 2 has some different properties. Then these properties are inherited into the object, although the value of attributes are similar in case of two objects, but the properties which they have inherited from their class, which they get from their class, is a different. Okay, then state. The state of an object consists of a set of data fields, its properties within their current values. So let's take example of this object. So dog is an object. So the state is name, color, breed, and okay, and behavior will be barking, fetching, wedging, and tall. Okay, so suppose the let's say there are the different attributes. So name is puppy, color is yellow, breed is suppose Labrador, and hungry status is yes or no. So suppose this will be the state. State is nothing but the set of attributes with their values. We have already discussed this earlier in case. Then behavior. Behavior is how an object acts and reacts in terms of its state changes and message passing. When you send a message to an object, you actually know some method. So whenever the objects have to interact with one another, what they do, they send a message to another object, and in the form of parameters, in the form of when we and how they talk to another objects by revoking their any method, the method of that object. We revoke that, we call that method in our program, and we communicate with different objects. Invoking a method will cause certain well-defined behavior and may changes the object state. The behavior may depend on the object's current state. So let's say uh, suppose we are calling one function in which we are using parameters which are dependent on the current state, like we are passing the parameters like length and width of a rectangle, and we are taking the area. We have to calculate the area of a rectangle, then the area of, and we are calling a method called to calculate the area of rectangle, then that method will be revoked. Okay, while Suppose let's say it is revoked by some another object, but that method, or you can say that behavior is dependent on the current state of object rectangle R1. Okay, the current state is what? Length and breadth equals to both are 5 centimeters, suppose. So that behavior depends upon the current state because it takes values of attributes from the current state, that are the length and breadth. Okay, then there are the different modifiers. These are modifiers alters the state of an object. Example, object name dot set net worth. So in operations there are the 4 different types of operations: modifier, selector, constructor, and destructor. Modifier modifies the values of an attribute. So let's say there is an attribute, so there is an object, there is an object O1, and there is an attributes like worth, net worth, then age in that attributes. So now I have to change the attribute net worth. So what will I do? I have to modify it. Then I will use object O1 dot set net worth. So set and get, these are the we can say set is a modifier operation. And then selector, so whenever we use object dot get any attribute, then get is an selector. Then selector access the state of an object but does not alter it. Okay, it only access the state of an object, it does not alter the state of an object, but modifier alters the state of an object. Okay, then constructor, it creates an object and initializes its state. For example, whenever we call any function, then there are some initiator operations which defines the value of an attribute to which initializes the value of attributes. And there are some destructors which destroys an object, frees its memory. So that's it. Then there is also state defines the objects, whereas the behavior defines the what object does. State defines what the object is, what is the current status of object, what is the current value of object. Okay, and the behavior defines what the object can perform, what the object can do. Objects are real-time entity which are created through their templates, their class. Real-time entity, that means they would occupy memory space in which they will save the values, create a state of an object, of its attributes. These values, since object occupy a space in memory, so they have unique address in a memory. This becomes the identity of an object. So this is all about objects and classes. Thank you.